Okay. Put on the record. Okay, so we realize this is an exponential equation because the variable is in the exponent. And the way we try to solve these exponential equations is by trying to get both sides of the equation written in terms of the same base. Obviously, this side is being written in terms of base 5. This is saying 5 to the 3x minus 1. Let's try and get 25 in terms of base 5, and that's pretty easy because 25 is 5 squared. So I can change this to 5 to the 3x minus 1 equals 5 squared. We will learn later in the lesson what to do when we can't get this in terms of the same base. But right now we can, so we put these both in terms of base 5. So now we can just look at the exponents. If the bases are the same, they have to be equal. So the 3x minus 1 has to equal the exponent 2 because it's exponent 2. And now this is a relatively simple equation to solve. We get 3x equals 3, which of course gives us x equals to 1. So the correct answer for x in this case is 1. A number of people did get that answer. Okay, the next question has to do with figuring out a log. This says the log base 49 of 7, and they want me to simplify it. In other words, they want me to tell you what is this equal to. So since we don't know what it's equal to, let's just call it x. You could call it any letter you want. We don't know what it is. And if you remember that what we usually do when we're dealing with logs is to change from the log format to the exponential format, simply because it makes much more sense to us. We're much more familiar with the exponential. And I have it written right over there. Log base b of a equals c is equivalent to, the base is b, the subscript is the base. So in this case, the base is going to be 49. The exponent is the number that's on the other side of the equal sign. It's what the logarithm is equal to. In this case, what's on the other side is an x. We don't know what it is. And that equals the number that's written right next to the word log, not the subscript, but the number right next to it. B to the c equals a. In other words, our a in this case is 7. So translating this from the log form to the exponential form gave us 49 to the x power equals 7. Now we do know what the relationship is between 49 and 7. We know that the square root of 49 is 7. But as I mentioned, in this chapter, we don't use radical signs. Instead of radicals, we use exponents. And the square root, the way we indicate the square root is by using the 1/2 power. The square root of 49 can also be written 49 to the 1/2 exponent. In other words, in this case, the x has to be equal to 1/2 because 49 to the 1/2 power, which means the square root of 49 is 7. So this is and a few people did get this answer that your x is 1/2. And what we noticed is that a lot of our logarithmic equations or questions can be solved if we go from the exponential form, the logarithmic form, to the exponential form. The other thing we had done on Tuesday is talk about what's called the properties of logarithms, or the logarithmic arithmetic, how to convert from working with logs to working with numbers or from working from regular numbers back to working with logs. And there were three basic rules that apply. The first rule is that if you do the log, now notice I didn't write any base here. When we don't write any base, it's understood that the base is 10. It's called a common log, and the base is understood to be 10. Now, the first rule is saying the log of x times y equals the log of x plus the log of y. Now, this applies to any base, not just base 10. It's just easier to write it without writing in those bases, but this applies to any base. And the rule makes sense because, again, what the log is an exponent. And we know when we're multiplying numbers, what we do to the exponents is we add them. We're multiplying the numbers x times y. So what we'll do to their exponents, to their logs, is we're going to add them. The second rule has to do with division. When we're dividing numbers, we subtract the exponents. So when we're dividing numbers, what we do to the logs is we subtract them. Again, the number in the numerator is always the one that gets the positive sign. If it has no sign, it means it's positive. And the number in the denominator always gets negative sign because you're dividing by the number in the denominator, so you're subtracting that exponent. And the third rule has to do with when you have a log of a number that has an exponent as well. And what that tells us is that that number, that exponent, becomes the coefficient. You just take the number that's in the exponent and move it on in front. Because we know the rule is when you have a number that has an exponent and you put a second exponent to it, let's say you have x squared and then you do to the third power, you take those two exponents, you multiply them. So this log x is one exponent, the n is another exponent. What you're doing is you're multiplying those two exponents. Easiest to remember is take the exponent and make it into the coefficient. So those were the basic rules of working with logs. And we looked at these both ways. We looked at it going from the contracted version to the expanded version. This is a single log to individual logs, or vice versa. We can take an expression that has a bunch of logs in it and compress it, contract it back to a single log, remembering the rules that if the two logs are being added, it means that we're multiplying the numbers. If the logs are being subtracted, means we're dividing the numbers. And if there's a number in front of the word log, that really is an exponent. And we're going to see how we can use these rules to solve exponential and logarithmic equations. So that's basically what we're left with. This is, I hope to finish most of the work. Let me just remind you that if you have not done test 3 on Delta Math, it really was supposed to have been completed by this morning, but if you haven't done it, you still can do it. You'll just have a somewhat reduced mark. You'll have 10 points taken off for it being late. Now, if you have a good reason for not having done it on time, just email me and I will extend the time you have to do that test. But you must do that test 3 on Delta Math. I also posted on CUNY Blackboard a pre-test for the final. It's a total of 40 multiple choice questions. You have 2 chances to take that test, and I will take the better of the 2 chances as your mark. So I'm giving you 2 opportunities to do that. That must be completed by Monday, December, I think it's the 13th is a Monday. Yes, Monday, the 13th. Which is a week from this coming Monday. The final exam will be during the week of the 13th. Again, I haven't had exact instructions as to when your exam is going to be given, so I haven't posted it yet. But as soon as I know, I will post it. But it'll definitely be the week of the 13th. Okay, so having said that, I want to first talk about solving logarithmic equations. And then I'm going to go from to talk about solving exponential equations, which are the last 2 topics that we are required to do. So let's say I have an equation that looks like this. Log base 5 of 3x equals 2. Where we have a log on one side and a number on the other side. We've mentioned the easiest way to solve those log equations is to change from the log expression to an exponential expression. Again, the subscript is going to be the number that gets the exponent. The number on the other side of the equal sign is going to be the exponent. So the exponent in this case is 2. This says 5 to the 2 equals 3x. It equals that expression that's sitting right next to the word log. If you compare this to that, you will see that's exactly what we've done. The base, the exponent equaling the number. And now, of course, I can solve this because 25 squared I know is 25. So this gives me 25 equals 3x. And therefore, my answer for x is 25 over 3. And you could leave it in that format as a fraction. So this is really nothing new. This is pretty much what we were doing last time in class. So what kind of other examples can we get that involve logarithmic equations? So let's say I gave you an equation that looks like this. Suppose I have this equation, log base 3 of x plus log base 3 of x minus 2 equals 1. And I want to solve this log equation. Now, I just told you the way we solve log equations is we try to change from the log format to the exponential format. But that method works when I have only one log on the side of the equation. I have a problem here. I have more than one log. So I can't go automatically to the exponential form. But I do remember from rule number 1 that there is a way to contract multiple logs into a single log. We know when we have 2 logs being added, we must have originally have been multiplying the numbers. If we would have had a minus between the 2 logs, it would have meant that we were originally had divided. So if I want to contract this back to a single log, I'm going to change this to log base 3 of x times x minus 2. Because the logs being added meant the 2 numbers, which are the expressions that are right next to the word log, were being multiplied. Now, x times x minus 2, of course, I could use a distributive property, will be x squared minus 2x. And now I have a log equaling a number. This is in a perfect setup to now go to the exponential form. The base here is going to be 3. The exponent is going to be the number that's on the other side of the equal sign, which is 1. And that's going to equal the number that's written, or the expression that's written right next to the word log, which is x squared minus 2x. And of course, 3 to the 1 is just 3. So this becomes the equation 3 equals x squared minus 2x. I right away recognize this as a quadratic equation. I have to solve this quadratic equation, and I'm going to solve it the way I've always solved. Let's write just a regular algebra equation now. I'm going to subtract 3 from both sides. So that'll go over here. I'll have x squared minus 2x minus 3 equaling 0. I just moved the 0 from the left side to the right side, just so it looks like more like what I'm used to. And of course, I'm going to do this using my AC method. My A is 1, my C is negative 3. So my AC is negative 3. And my B is negative 2. So I'm looking for 2 numbers that when I multiply them will give me negative 3. But when I add them or combine them, they're going to give me negative 2. I think everybody will realize it's negative 3 and positive 1. So I'm going to write this as x squared minus 3x plus 1x. So the negative 3x and the 1x give me my negative 2x minus 3. And I'm going to factor each group. So here I'm going to take out the x and get x minus 3. Over here, there's no common factor, so I'm just going to do plus 1 times x minus 3, which gives me, of course, x minus 3 in one parentheses, and in my other parentheses, I'm getting x plus 1. And now I set each of these equal to 0. So x minus 3 equals 0. Bringing the 3 to the other side gives me one answer being x equals 3. And x plus 1 equaling 0 gives me another answer, which is equal to x minus 1. So it looks like I have 2 answers to this question, except there's something I have to be very careful about. It's possible to have what's called an extraneous root in a log equation. An extraneous root means a number that came out as part of the proper way of solving it. I did everything correctly, but the answer doesn't work. And the reason you might get an extraneous root in a log equation is because you are never allowed to take the log of either a negative number or 0. In other words, the number that's right next to the word log always has to be positive. So when my x is 3, log 3, that's good. And this is 3 minus 2, which gives me 1, which is also positive. So when x is 3, this is a good answer. Both the x and the x minus 2, those are the numbers that you're taking the logs of, are positive numbers. But when you try using -1 as your answer, you're right away in the first example, log of -1. I don't even have to look any further. This is no good because we cannot do logs of negative numbers. So the only right answer to this equation is x equals 3. And this is how you can solve a logarithmic equation that has more than one log in it. I'm going to give you one to try while I take attendance. So here's the equation. Log x plus log x plus 3 equals 1. See if you can solve that log equation while I take attendance. Maury Alabre. Chelsea. Hi, good afternoon. Ariana.
Here, hello.
Hi. And I see, Maury, I see you came on also. Adina.
I'm here.
Hi. I always like hearing your happy voice. Always have such a peppy voice. It's so nice. Lachey.
I'm here.
Hi. Kava, I know you're here because I saw you always nice and early.
Yeah, I'm here.
Yeah. Terrence. I'm pretty sure Terrence is here.
Good afternoon.
Yeah, I thought I saw you before. Okay. Karide. I think I saw you here before also. Hi, Karide. Kizia.
Did you say Kezia?
Yes, hi, how are you?
Oh, hi, I'm here. I'm good, how are you?
Faith. Ethan. Isabella. Serenity. Reggie. Reggie, I'm pretty sure I saw you here before.
I'm here.
Did you say Sky Powell?
Hey, Isabella, I did say you. Okay. Who else did I? Zamia. Brandon. Michaela.
Here.
Hi, Michaela. Seraphine.
I'm here.
Hi, Seraphine. Marissa. Renee. Hi, Renee. Sky, I saw you had already sent me in. Jaden. Kennedy. Felicia, so that you were here. Michael. Oh, hi, Kennedy. I see you here. Natalia.
Here.
Hi. And Michael, I see you're here. Cassidy. Megan. Kalia. Lauren.
Here.
Hi.
Hi.
And Kayla Zachary.
Here.
Hi.
Hello.
Okay. And I see that one person has already answered the question, Reggie, who's always on the ball there. Let's see if anybody else comes up with an answer. I'll give you a couple minutes. Okay, so a couple of people have come up with the answer too. Let's see if that is the correct answer. So again, just like we had before, we have a problem where we have two logs on this side. So what we're going to do is we're going to contract this back to a single log. Again, I see the sign between them is plus. That means I must be multiplying the numbers. In other words, as a single log, this becomes x times x plus 3. So we change this plus, the adding of the logs, into multiplying of the numbers. So using the distributive property, this gives me x squared plus 3x. And now, since we have a single log equaling a number, we can go from the log format to the exponential format. And we see there's no base written in here, which means we're dealing with common logarithms, and my base is understood to be 10. So this is 10 to the 1 power equals x squared plus 3x. So now, this obviously is 10 equals x squared plus 3x. Again, I have a quadratic equation. I'm going to subtract 10 from both sides. And this will give me x squared plus 3x minus 10. And that's equaling to our 0. And again, like in any quadratic equation, we're going to try and factor. So again, I'm using my AC method, where my AC is negative 10 and my B is positive 3. So I'm looking for two numbers that are going to multiply to negative 10, but when I combine them, they're going to give me a positive 3. Well, obviously one number is going to be positive and one number is going to be negative. And I think it's sort of obvious that the number should be positive 5 and negative 2. Because 5 times negative 2 is negative 10, and 5 plus negative 2 gives me positive 3. And here my common factor is x, so this becomes x times x plus 5. And here my common factor is negative 2, and that also gives me an x plus 5. So I get x plus 5 in one parentheses, and in my other parentheses, I get x minus 2. Now, I said each of these equal to 0, so x plus 5 equals 0. I think everybody realizes is negative 5, and x minus 2 equals 0 gives me x equals 2, positive 2. And just like before, the negative, since this is an x, as soon as x is negative, we cannot use it. We have to throw out or exclude the negative 5. But the 2 works because this is positive and 2 plus 3 is 5, which is also positive. So my one answer is x equals 2, which is what a number of people have given as the answer. Let's just do one where instead of having a plus in between them, there's a minus, just as a little bit of practice. So let's do one more. log base 3 of x plus 3 minus log base 3 of x minus 1 equals, see if you can solve that equation. Right, we have one answer so far. Let's see if anybody else. Okay, let's try this out. Now, again, we have more than one log on a side. We want to contract it into a single log. So we're going to, since this says minus, we're going to rewrite this as log base 3 of x plus 3 over or divided by x minus 1. The minus is telling us that you are dividing, and be careful, the ones that are positive are the ones that go on in the numerator, and the negative ones, the one that's being subtracted, goes in the denominator. And that's equal to 1. So here we have it now as a single log. So now we can go from the log format to the exponential format. My subscript is 3, so my base is going to be 3. The number that's on the other side of the equal side is my exponent is 1. And that gives me the x plus 3 over the x minus 1. Now, 3 to the 1 really is just plain 3. And I'm going to write this as 3 over 1 so that I can solve this equation by cross multiplying. This is a proportion, so since this was just a 3, it's easier to write it as 3 over 1. Again, whatever this number in becomes the exponent, and that 3 to that exponent, which is 3 to 1, just gave us 3. Now cross multiplying, I'm getting 3x minus 3, this times this, equals x plus 3. And I'm going to bring the x's to the left side, which will give me 3x minus x, which is 2x minus 3 equals 3. And then I'll add 3 to both sides. So that comes out to be 2x equals 6. And the answer I got was x equals 3. And just checking it, when I put in the 3 over here, this becomes 3 plus 3, which is 6, so that's positive, that's okay. This is 3 minus 1, which is 2, that's also positive. So this answer, in this case, it was only one answer, and it was, there are times that the one answer you get just doesn't work because it makes it, so sometimes you might not have a solution. Okay. Just to do one more example like this, in which it's not equal to 1. Let's try one more example. Excellent. What if I had given you this equation? Log base 2 of x plus 2 plus log base 2 of x equals 3. See if you can solve that one. Okay, let's try this together. Again, in this case, I again see a plus between the logs. So I am going to have to multiply these two things together. So I'm going to rewrite this as log base 2 of x plus 2 times x. That's going to be equal to my 3. This plus contracts into a multiplication. And this, of course, is x squared plus 2x. So we have log base 2 of x squared plus 2x equaling 3. Now here, be careful. You have to now go to the exponential form. You change from a logarithmic form to exponential. You put your base as 2. Your exponent is 3. That's equal to the x squared plus 2x. So this 2 to the 3, 2 times 2 times 2 gives me 8. This is 8 equals x squared plus 2x. Most common mistake is that people take this x squared plus 2x and set it equal to 3. It's not 3, it's 2 to the 3 because the base is 2 and this 3 on the other side is the exponent. So now I'm going to, this is a quadratic equation, and I'll bring the 8 to the other side. You notice the questions are very similar, one after the other. So we get x squared plus 2x minus 8 equaling our 0. So now using our AC method, our AC is negative 8 and our B is positive 2. So what numbers multiplied in negative 8, but when I combine them or add them, give me positive 2. I think it's obviously that the numbers are going to be 4 and 2, and it's going to be a positive 4 and a negative 2. Because 4 times positive 4 times negative 2 does give me negative 8, and positive 4 plus negative 2 gives me positive 2. And here I'm going to factor out the x. I'm going to get x times x plus 4. And here I'm going to factor out a negative 2, and that's going to give me x plus 4 as well. So it factors into x plus 4 and x minus 2 as the factoring of this x squared plus 2x minus 8. So this gives me x plus 4 equal to 0, which gives me x equals to negative 4, and x minus 2 equals 0 gives me x equal to 2. And the negative 4 won't work because if I put in negative 4 here, negative 4 plus 2 gives me negative 2. It certainly won't work. It wouldn't work in here also, but I don't have to go any further. The x equal 2 does work because 2 plus 2 is 4 and 2 is 2. It's positive. So my answer is the one answer. Again, after you do all the solutions, you might have a situation where no solution works, 2 solutions work, or 1 works and 1 doesn't. Could be any one of those situations. Okay. Let us now look at solving. This is solving logarithmic equations. I want to go on to solving exponential equations. We already, at the beginning of the class, we even talked about solving a quadratic, an exponential equation. But what if I had something that looks like this? 3 to the x equals 17. Obviously, this is an exponential equation. We're looking for the exponent that we can put to 3 to get us to 18. Well, if I think about the powers of 3, 3 to the first power, 3 to it is 3. 3 times 3, or 3 squared, is 9, and 3 to the third is 27. We never hit 17. It's not like a 3 on one side and an 81 on the other side, where we could get to 81 by doing 3 multiplied 4 times. I'm never going to get an exact number as an exponent that will give me 17 as an answer. So I'm going to show you an alternate way to solve these exponential equations. What I'm going to do is I'm going to just put the word log in front of both of these. If 3 to the x equals 17, the log of 3 to the x will equal the log of 17. Now, notice I didn't put log base 3 here. I actually put just plain log. In other words, I'm using the common log. I'm going to do this because on my calculator, I have the common logarithms written. You should see on your calculator a button that says LOG. Now, it just says LOG. It doesn't say LOG base B or anything. It just says LOG, because this is a button that has to do with common logarithms in which the base is 10. That's what a common logarithm. There happens to be another button on your calculator that has to do with logs. It's actually called ln. There is a number called E, which is approximately 2.718, etc. It's a irrational non-ending, non-repeating decimal that pops up in certain situations in terms of very important formulas that banks use. It's used in the population questions. Happens to be a very important number. It's called the natural number. Don't ask me why it's called the natural number, because to me it looks totally unnatural. It's not an whole number. It's not an exact number. You can go to as many decimal places as you want, but you're never going to get to an exact answer. We call it E just because it's easier to call it that than to call it 2.718, et cetera, et cetera, et cetera. It's like the number pi is an irrational number. This is an irrational number. It happens to be used as the base of what's called the natural logarithm. ln really stands for log base E. Now, you wouldn't do a log base E in a normal situation, but as I said, it comes up in certain formulas, so you will have this on your calculator. So if you see these two buttons, there's this log button, which stands for the log base 10. And then there's this ln button, which stands for the log base E. I just want you to be aware of it. Really, for our purposes, you don't need it. When you go into a calculus class, this will become very important. Okay, so when I put the word log in front of each of these, I actually was talking about the log base 10. And the reason I did log base 10 is because I'm going to want to use my calculator. Here's what I do. Going back to this problem. Since these are now I said if the two numbers are going to be equal, their logs are going to be equal. And the advantage of logs is that we have this rule over here. When you have a log, the exponent then becomes the coefficient. So I can rewrite this as x log 3 equals log 17. And if I want to get the x alone, I just have to divide out by this log 3. And this is something I can't do in my head, but I certainly can go to my calculator, press my log button. It usually comes up with a parenthesis, so I'll close the parentheses, put in the 17, I'll put in divide, I'll press my log button again, and I'll put in my 3, and then I'll put in equal, and it will give me the answer to this. That's the advantage. Log base 10 is programmed into your calculator. You could have done this using ln's, just like you could do it with logs. Okay, so here I'm on log 17, close my parentheses, divide log 3, and I get a long decimal, 2.5789. It goes on and on. Most of the answers here are going to turn out to be irrational numbers, in other words, very long decimals. Let's say we were told to find this to the nearest hundredth. So then I go to this decimal. Hundredth is 2 decimal places. The next number is 8. So that answer would be 2.58. And you could check it. 3 to the 2.58. If you do it on your calculator, you do have an exponent button. 3 exponent 2.58 gives me 17.02, etc. The reason it's not exactly 17 is because I rounded this. If I would use this, if I didn't use a rounded version, it would be more accurate. But that is a way of solving an exponential equation when you cannot write both numbers in terms of the same base. Here, let me give you one to try now. No, leave the pro. Here, let's say I give you 8 to the 2x equals 5. See if you can solve it to the nearest 10th. Okay. Okay, let's do this together. So we're trying to solve this equation, 8 to the 2x equals 5, and there's no way I can get 5 and 8 written in terms of the same base. So I have to use my logarithm method. So again, I'm going to write the word log in front of both of these expressions. So we're going to get 8 log 8 to the 2x equals log 5. And because I now have logs, I can take this exponent and put them in front. So this will become 2x log 8 equals log 5. So the first thing I'm going to do is I'm going to divide out. I want to get rid of this log 8. So I'm going to divide both sides by log 8. And that I have to do, remember, I'm doing log base 10, so I can use my calculator. So I'm going to do log 5 divide by log 8. And I get that here I'm left with 2x equals 0.773976. Next number is 0316. I don't have to write the whole thing out. But that's what 2x is, and I don't want what 2x is. I want what x is. So now I'm going to have to divide this whole thing by 2. So it's in my calculator. I'm just going to do divide by 2, and it comes out to 0.3869880158. That's what I'm getting. I put the whole thing in. And I asked you to find the answer to the nearest tenth. Now, tenth means 1 decimal point. So this is 0.3. The next number is an 8, so the answer would be 0.4. Be careful to round off to what you are asked to round off. The nearest tenth is 1 decimal. The nearest hundredth is 2 decimals. Okay. I think I'm going to stop here. We almost completed everything in the syllabus. We have a little bit of review of things to do. If you have any particular topic that you'd like me to review sometime next week, send me an email and I will spend some time doing that topic. Don't forget, if you haven't done the Delta math test yet, to do it. And also don't forget to do the test on CUNY Blackboard. It's a review. It's basically a prep for the final, and it's 40 multiple choice questions. Your final actually will consist of 30 multiple choice, though there are quite a few questions on the exam on these logs and exponentials. So this is an important topic for you to know. Okay, have a nice weekend. If anybody has any questions.
Have a good one, Professor.
Okay, have a great weekend, and I'll see you on Tuesday again. And don't forget, this is crunch time. Do as much of your work as you possibly can now. Don't leave it for the last day. Bye-bye.